Hello, in this lecture we will find the value of x in two different methods. In the drawing we have quadrilateral SRPQ, angle SRP, this angle equals to 65 degrees, angle PRQ equals to 50 degrees, and we also know that side SP equals to side SQ, so we actually will define side SP as Y, then side SQ will be also equal to Y according to our definition, and we want to find out the value of angle PSQ, this angle that also equals to x. Okay, so we will start with the first method. In the first method we will make a construction. We will extend side QR and then from point S we will draw a perpendicular to the extended QR. So this angle will be equal to 90 degrees. It is a right angle, and we will define the touching point between the perpendicular from point S as N. Again, the touching point between the perpendicular to the extended QR is defined as point N, and we will also draw a perpendicular from point S to PR. So this angle equals to 90 degrees, and this angle is also a right angle. It equals to 90 degrees. And we will define the touching point between the perpendicular to PR as point M. And so what is the size of this angle? Actually, QR is one side of the quadrilateral SRPQ is a straight line, and we extended the straight line QR by a straight line, so QN will remain a straight line. Again, QN is a straight line, so we write it down. QN is a straight line. QN is a straight line, and we have the rule that the sum of the angles on one side of a straight line equals to 180 degrees. So that is to say, if we focus at point R, and on this side of the straight line QN, then the sum of the angles at point R must be equal to 180 degrees. So that is to say we will get that the sum of the angles at point R is actually 50 degrees plus 65 degrees plus the size of this angle. We will define this angle as angle Z plus the size of angle Z must be equal to 180 degrees according to the rule that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we look on this side of the straight line QN and we focus on point R, the sum of the angles must be equal to 180 degrees. That is to say 50 degrees plus 65 degrees plus the size of angle L plus the size of angle Z must be equal to 180 degrees. So here we will subtract 50 degrees from this equality. We will get that 65 degrees plus the size of angle Z must be equal to 180 degrees minus 50 degrees is 130 degrees. So here we will subtract 65 degrees from this equality and we will get that angle Z equals to 130 degrees minus 65 degrees is 65 degrees. So we found out that the size of angle Z is actually 65 degrees. So we write here that angle SRN equals to 65 degrees. Okay, so in the next step we will focus on the right triangles, the small right triangle SMR, and the other small right triangle SNR, this right triangle. So actually on these two small right triangles we have a common side. SR belongs to both triangles, so we can write down that SR equals to SR is a common side. SR equals to SR, it is a common side. Side SR equals to SR is a common side that belongs to both triangles. We also have here two angles that are right angles, therefore they are equal to each other. So angle SMR in triangle SMR equals to angle SNR in triangle SNR, and they are both equal to 90 degrees. They are right angles. Again, angle SMR equals to angle SNR, and they are both equal to 90 degrees. They are right angles. And also we have those two angles that are equal to each other. They are both equal to 65 degrees. So angle MRS is equal to angle NRS, and both angles equals to 65 degrees. Okay, so angle MRS equals to angle NRS, and both angles equals to 65 degrees. But what is the size of this angle? We know that the sum of the angles in any triangle is equal to 180 degrees. And we have two angles, that one of them is equal to 65 degrees and the other one equals to 90 degrees. So in total, the sum of those two angles is equal to 90 degrees plus 65 degrees is 155 degrees. So according to the rule that the sum of the angles in any triangle equals to 180 degrees, so the size of this angle, the third angle, must be equal to 180 degrees minus 155 degrees. So the size of angle MSR is actually equal also to the size of angle NSR, because they have two equal angles, 65 degrees and 90 degrees. So the size of angle MSR is equals to the size of angle NSR, and the size of this angle equals to 180 degrees minus 155 degrees. 155 degrees is the sum of the two other angles, and 180 degrees minus 155 degrees equals to 25 degrees. So we found out that the size of those two angles are equal, each one equal to 25 degrees, and they are equal to each other, of course. So we actually found out that all the three angles of the right triangle SMR are equal to all the three angles of the right triangle NSR, and and we also have a common side that belongs to both triangles, SR. So we actually proved that the right triangle SMR, this right triangle SMR is congruent. This is the sign of congruent. Triangle SMR congruent to triangle SNR. According to side angle rule. So what is side angle rule? Side angle rule is that if you prove that two angles of one triangle and the side that attach to those two angles in one triangle are correspondingly equal to two angles and the side that attached to those two angles in another triangle, then you actually proved that those two triangles can go into each other according to side angle rule. And we actually proved that those two angles and the side that attached to those two angles, that is to say SR, are corresponding equal to those two angles and the side that is attached to those two angles, that is to say SR. Therefore we proved that those two right small triangles can go into each other according to side angle rule. So from the fact that those two triangles can go into each other, we can conclude that SM, side SM of triangle SMR is equal to side SN of triangle SNR. So I will write it down. Side SM of triangle SMR is equal to side SN of triangle SNR, of the right triangle, triangle SNR, according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore those two corresponding sides will be equal to each other. Okay? So we proved that side SM equals to side SN. In the next step, we will focus on the right triangle SMP, and the right triangle SNQ. And we will prove that those two right triangles can go into each other. First of all, we proved right now that SM equals to SN. So we can write down that SM equals to SN. SM from triangle SMP equals to SN from triangle SNQ. SM equals to SN. We also know that SP equals to SQ and they're both equal to Y from our definition. That the fact that SP equals to SQ is given us in the question, and we defined SP as Y, so SP equals to SQ equals to Y. Again, SP equals to SQ equals to Y. And we have side PM of triangle SMP. We will actually prove that side PM of triangle SMP is equal to side NQ of the right triangle, triangle SNQ. Okay, we will prove that PM equals to NQ. You should remember that both triangles are right triangles, so we can use the Pythagoras theorem in order to calculate the sizes of PM and NQ. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So if we focus on the right triangle, triangle SMP, according to the Pythagoras theorem, SM square plus PM square, or SM square plus PM square, will be equal to SP square. Again, if we focus on the right triangle, triangle SPM, according to the Pythagorean theorem, in the right triangle, triangle SPM, SM square plus PM square equals to SP square. Okay, so here we will subtract SM square from this equality, and we will get that PM square equals to SP square minus SM square. Okay, so here we will take a root out of this equality, and we will get that PM equals to the root of SP square minus SM square. PM equals to the root of SP square minus SM square. So in the next step we will focus on the right triangle SNQ. So in the right triangle SNQ, according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say Sn square plus NQ square will be equal to SP square. Again, in the right triangle SNQ, according to the Pythagoras theorem, Sn square plus NQ square equals to SP square. Here we will subtract Sn square from this equality, and we will get that NQ square is equal to SP square minus Sn square. So here we will take a root out of this equality, and we will get that NQ equals to the root of SP square minus Sn square. Okay, so we found out the value of NQ. Actually, as you can see here, that PM is actually equals to NQ. Why? Because those two expressions are equal to each other. Why? Because actually SP equals to, actually in the right triangle SNQ, we know that Sn square plus NQ square equals to SQ square. So here we have SQ square again. In the right triangle SNQ, Sn square plus NQ square equals to SQ square. So we found out that NQ equals to the root of SQ square minus Sn square, but because of the fact that those two expressions are equal to each other, we can conclude that PM equals to NQ. Why those two expressions that are in the root are equal to each other? Because of the fact that SP is equal to SQ, which is given us in the question. SP equals to SQ, they are both equal to Y. And we also know that SM equals to We also know that SM equals to SN. SM equals to SN. Again, we know that SP equals to SQ according to what is given us in the question. And we also know that SN equals to SM. We have already found out that SM equals to SN. So actually those two expressions are equal to each other. Therefore, we can conclude that PM equals to NQ. PM equals to NQ. PM equals to NQ. So we actually proved that the three sides of the right triangle SMP are correspondingly equal to the three sides of the right triangle SNQ. Therefore, we actually proved that the right triangle SNP is congruent. This is the sign of congruent to the right triangle SNP. According to side rule. So what is side rule? Side rule is that if you prove that three sides of one triangle are correspondingly equal to three sides of another triangle, then you actually prove that those two triangles can go into each other according to side rule. And we proved that three sides of the right triangle SMP are correspondingly equal to three sides of the right triangle SNQ. Therefore, we proved that those two triangles can go into each other according to side rule. So from the fact that those two right triangles can go into each other, we can conclude that those two angles are equal to each other. Those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. We know that we proved that those two triangles can go into each other, therefore those two corresponding angles will be equal to each other. That is to say, angle SPM of triangle SPM is equal to angle is equal to angle SQN of triangle SQN according to the rule that corresponding angles in congruent triangles are equal to each other. So if we define angle SPM as theta, then angle SQN will be also equal to theta because of the fact that those two angles are equal to each other. So we found out that angle SPM equals to angle SQN, and they are both equal to theta according to our definition. So in the next step I will present to you a new rule, and we'll use this rule in our drawing. So rule number 1 states that if line segment, if a line segment subtends two equal angles on the same side, then the quadrilateral is inscribed by a circle and the 4 points lie on that circle. So I read all number 1 again. All number 1 states that if a line segment subtends two equal angles on the same side, then the quadrilateral is inscribed by a circle and the 4 points lie on that circle. So as you can see on the drawing, we have two equal angles. Those two angles are both equal to theta, and those two angles are both equal to theta, and they both subtend on the same line segment SR. This angle subtends on the line segment SR, and this angle theta subtends on the same line segment SR. So therefore, according to rule number 1, the quadrilateral SRPQ, this quadrilateral is inscribed by a circle, and the 4 points SR, P, and Q lie on that circle. Okay? So, actually, according to rule number 1, because of the fact that those two equal angles subtend on the same segment line as R, then the quadrilateral SRPQ is inscribed by the red circle, and the 4 points S, R, P, and Q lie on that circle. Okay, so actually that is the implementation of rule number 1 in our drawing. Okay. Okay. So I'll repeat again. According to rule number 1, we have here two equal angles. Both those two angles are equal to theta, and they subtend on the same segment line SR. Therefore, according to rule number 1, the quadrilateral SRPQ is inscribed by a circle, and the 4 points SR, P, and Q lie on that circle. So as you can see, points SR, P, and Q lie on the circle. Okay, that is the implementation of rule number 1 in our drawing. And we also have rule number 2. Actually, rule number 2 states that peripheral angles that subtend on the same chord are equal to each other. So I will read rule number 2 again. Rule number 2 states that peripheral angles that subtend on the same chord are equal to each other. Okay? And again, we can implement rule number 2 in our drawing. As you can see from our drawing, we have here two peripheral angles, angle X and angle PRQ, that equals to 50 degrees. Both of those two angles subtend on the same chord, chord PQ. And because of the fact that both those two angles subtend on the same chord, chord PQ, therefore, according to rule number 2, they are equal to each other. That is to say, X equals to 50 degrees. So X equals to 50 degrees according to rule number 2. Again, we found out that X equals to 50 degrees according to rule number 2. Why? Because we have here two peripheral angles, angle X and angle PRQ, that equals to 50 degrees. Both those two angles subtend on the same chord PQ. Therefore, according to rule number 2, they are equal to each other. That is to say, X equals to 50 degrees. X equals to 50 degrees according to rule number 2. So, we finished with method 1. And in the next step, we will find out the value of X, of the size of angle X, according to method 2. So, in the second method, we will do other construction. We will actually extend side QR, we will extend side SR, we will extend side SR, and then from point Q we will draw perpendicular, or we will raise perpendicular to the extended SR. So actually this angle equals to 90 degrees because we raised perpendicular to the extended SR, and we will define the touching point between the perpendicular to the extended SR line segment as we'll define this point as point M. Okay, and in the next step we will extend QM in such a way that Q dash M will be equal to QM. Again, Q dash M will be equal to QM according to our construction. We built it like that. We extended QM until Q dash M equals to QM. And in the next step, we will join together points R and Q dash by a straight line. And then we will join together points S and Q dash by a straight line. So, first of all, we extended SR. SR is the side of a quadrilateral SRPQ, therefore it is a straight line, and we extended the straight line SR by a straight line, so SM will remain a straight line. So I write it down that SM is a straight line. SM is a straight line. And we have the rule that I mentioned already in method 1, that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the bottom side of the straight line SM at point R, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So at point R, at the bottom line of the straight line SM, the sum of the angles equals to 180 degrees. So which angles we have at point R on the bottom line of the bottom side of the straight line SM at point R? We have 50 degrees plus 65 degrees plus, we define this angle as angle Z. So the sum of the angles on one side of a straight line equals to 180 degrees. Therefore, it must be equal to 180 degrees. So we got this equality, as I have already did in the first method. We subtract 50 degrees from this equality, then we'll subtract 65 degrees from this equality, and we will get that angle Z equals to 65 degrees. So angle Z equals to 65 degrees. here QM is perpendicular to the extended SR, so QM is perpendicular, it is a straight line, and then we extended the straight line QM by a straight line. So QQ dash will remain a straight line. QQ dash is a straight line. So I write it down that QQ dash is a straight line. And again we have the rule that states that the sum of the angles on one side of a straight line equals to 180 degrees. So if we focus on this side of the straight line QQ dash at point M, the sum of the angles must be equal to 180 degrees. So here we have 90 degrees plus the size of this angle that we will define as angle L must be equal to 180 degrees. So we will get that 90 degrees plus the size of angle L equals to 180 degrees. Here we will subtract 90 degrees from this equality and we will get that the size of angle L is actually 180 degrees minus 90 degrees is 90 degrees. So it is a right angle. We found out that angle Q dash MR is a right angle. It equals to 90 degrees. So we actually have at point M two right angles. Okay, this right angle and this right angle. So in the next step we'll focus on the right triangle QMR and the right triangle Q dash MR. And we will actually prove that those two right triangles can go into each other. Okay, so we will focus on the right triangle QMR and the right triangle Q dash MR. On those two right triangles, we know that QM equals to Q dash M. QM equals to Q dash M according to our construction. QM equals to Q dash M according to our construction. QM equals to Q dash M according to our construction. Those two angles are equal to each other, both equals to 90 degrees, they are right angles, so we can write down that angle QMR is equal to angle Q dash MR, and both those two angles are equal to 90 degrees. Okay, so angle QMR equals to angle Q dash MR, and both angles are equal to 90 degrees. Okay, and we have here a common side. RM is a common side, it belongs to both triangles, so we can write down that RM equals to RM. It's a common side that belongs to both triangles. So RM equals to RM is the current side, so we actually proved the triangle, the right triangle, triangle QMR, congruent to the right triangle, triangle QDSMR, according to side angle side rule. So I write it down. Triangle QMR congruent to triangle QDSMR according to side angle side rule. Okay. So what is side angle side rule? Side angle side rule is that if you prove that two sides and the angle between them of one triangle are corresponding equal to two sides and the angle between them of another triangle, then you actually proved that those two triangles can go into each other according to side angle side rule. And we actually proved here that those two sides and the angle between them in triangle QDSMR are corresponding equal to those two sides and the angle between them of triangle QMR. Therefore, we proved that those two triangles can go into each other according to side angle side rule. So from the fact that those two triangles can go into each other, first of all, we can conclude that those two angles are equal to each other, according to the rule that corresponding angles in congruent triangles are equal to each other. So if this angle equals to 65 degrees, then this angle will be also equal to 65 degrees. That is one thing. So angle QMR equals to angle QDSMR, and they are both equal to 65 degrees. That is one thing. And the other thing that we can conclude is that QR equals to QDSR. Again, QR equals to QDSR. QR equals to QDSR according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides will be also equal to each other. Actually it is RQDS, and RQDS is here. Actually RQDS is here. Okay. So we proved that those two angles are equal to each other and they are both equal to 65 degrees, and that side RQ equals to side RQ. So in the next step, actually first of all we know that SP equals to SQ, so if we define SP as Y, then SQ will be also equal to Y because of the fact that they are equal to each other. So in the next step we will focus on the right big triangle, triangle QMS, and on the other right big triangle, triangle QDSMS. Okay? So on the right big triangle, triangle QMS, and the right big triangle, triangle QDSMS. And we will prove that those big right triangles can go into each other. Again, we will focus on the right big triangle, triangle QMS, and the right big triangle, triangle QDSMS, and we will prove that those two triangles can go into each other. First of all, we know that QM equals to QDSM according to our construction. QM equals to QDSM according to our construction. We also know that those two angles are equal to each other and they are both equal to 90 degrees. So angle QMS is equal to angle Q dash MS, and they are both equal to 90 degrees. Okay, angle QMS equals to angle Q dash MS, and they are both equal to 90 degrees. And we have a common side. The common side SM belongs to both triangles, so we can write down that SM equals to SM. It is a common side. SM equals to SM as a common side. And again, we actually proved that those two triangles, triangle QMS can go into triangle QDSMS according to side angle side rule. So I write it down. We found out that triangle QMS can go to triangle QDSMS according to side angle side rule. Okay, I'll repeat again. Triangle QMS can go into triangle QDSMS according to side angle side rule. We proved that those two sides and the angle between them are correspondingly equal to those two sides and the angle between them on the other triangle. So we proved that those two triangles can go into each other according to side angle side rule. And from the fact that those two triangles can go into each other, we can conclude that QS equals to Q dash, SQ equals to SQ dash. So SQ equals to Y, so SQ dash will be also equal to Y because of the fact that they are equal to each other. SQ dash will be also equal to Y. So QS equals to Q dash S. QS equals to Q dash S, and they are both equal to Y. Again, QS equals to Q dash S according, and they are both equal to Y, and they are equal to each other according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides will be also equal to each other. That is to say, SQ will be equal to SQ dash, and they are both equal to Y according to our definition. Okay, so in the next step, we will focus on the triangle SRQ and triangle SRQ dash, and we will prove that those two triangles can go into each other. Okay, we will focus on triangle SRQ and SRQ dash. So we have already found out that RQ equals to RQ dash. RQ equals to RQ dash. RQ equals to RQ dash according to what we have already found out. We just right now found out that SQ equals to SQ dash equals to Y. SQ equals to SQ dash, and the both sides are equal to Y. SQ equals to SQ dash, and both sides are equal to Y, and we have a common side. SR is a common side, it belongs to both triangles, so if SR equals to SR, it's a common side that belongs to both triangles. So SR equals to SR is the common side. So we actually proved that the three sides of triangle SRQ correspondingly equal to the three sides of triangle SRQ dash. Therefore, we proved that those two triangles can point to each other according to side rule. So I write it down. So actually, triangle SRQ congruent to triangle SRQ dash. Triangle SRQ congruent to triangle SRQ dash according to side rule. So what is side rule? Side rule says that if you prove that all the sides of one triangle are correspondingly equal to all the sides of the other triangle, then you actually proved that those two triangles can go into each other according to side rule. Okay? From the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding angles, those two corresponding angles will be also equal to each other. So we can write down that angle SQR is equal to angle SQ dash R angle SQR equals to angle SQ dash R according to the rule that corresponding angles in congruent triangles are equal to each other. And if we define angle SQR as theta, then angle SQ dash R will be also equal to theta. Okay, so SQR equals to angle SQ dash R, and they are both equal to theta according to our definition. So in the next step, we will prove that line segment PQ dash is a straight line. Okay? So actually, what is the size of angle PRQ dash? If we look on this side, the size of angle PRQ dash is equal to 65 degrees plus actually here we have actually when we calculated this after we extended SR, we calculated here actually from the drawing itself, as you can see, this angle is actually equals to 50 degrees. Actually, as you can see from the first method, angle SRM equals to 65 degrees and angle MRQ equals to 50 degrees. Okay, so here this angle SRP equals to 65 degrees, and this angle PRQ equals to 50 degrees. And okay, so here, what is the sum of the angles, or what is the size of angle PRQ dash? The size of angle PRQ dash is 50 degrees plus 65 degrees plus 65 degrees. Okay, again, the size of angle PRQ from this side equals to 50 degrees plus 65 degrees plus 65 degrees. 65 degrees plus 65 degrees is 120 degrees, and 120 degrees plus 50 degrees equals to 180 degrees. So we actually found out that angle PRQ dash equals to 180 degrees. Angle PRQ dash equals to 180 degrees. So because of the fact that this angle PRQ dash equals to 180 degrees, we can conclude that line segment PRQ dash is a straight line. PRQ dash is a straight line, and from the fact that PRQ dash is a straight line, we can conclude that PQ dash is also a straight line. Okay, so PQ dash is a straight line. And from the fact that PQ dash is a straight line, we can conclude that the shape PSQ dash is a triangle. The shape PSQ dash is a triangle, PSQ dash is a triangle. So in triangle PSQ dash, there are the big triangle PSQ dash, we have two sides that are equal to each other. That is to say, PS equals to SQ dash, PS equals to SQ dash, and they are both equal to Y according to our definition. So in triangle PSQ dash, PS equals to Q dash, and they are both equal to Y. And we actually have a rule that states that in front of equal sides in the triangle there are equal angles. In front of equal sides in the triangle there are equal angles. So in front of these two sides we have those two angles, and those two angles are equal to each other according to the rule that I mentioned. In front of equal sides there are equal angles, so those two angles are equal to each other because of the fact that they are located in front of equal sides Y and Y. So therefore they are equal to each other, but we know that this angle equals to theta, so this angle must be also equal to theta because of the fact that those two angles are equal to each other. So we found out that those two angles are both equal to theta. So from now on, from this point, we will continue as we did in method 1. And in method 1, we actually presented to you rule number 1 that states that if a line segment subtend two equal angles from the same side, then the quadrilateral is inscribed by a circle and the 4 points lie on that circle. So actually, according to rule number 1, because of the fact that those two equal angles both equal to theta and they subtend on the same segment line SR. Therefore, according to rule number 1, the quadrilateral SRPQ is inscribed by a circle, as you can see from the drawing. Indeed, the quadrilateral SRPQ is inscribed by a circle, and the 4 points SRPQ lie on that circle. As you can see from the drawing, the 4 points SR, Q and P indeed lie on that circle that inscribes the quadrilateral SRPQ. Okay, so actually that is the implementation of rule number 1 in our drawing. And we have also rule number 2. Rule number 2 states that if you have peripheral angles that subtend on the same chord, then they are equal to each other. And here we have two peripheral angles, angle X and angle PRQ, that equals to 50 degrees, and they both subtend on the same chord called PQ. Again, angle X subtend on chord PQ, and angle X subtend on chord PQ, and angle PRQ that equals to 50 degrees also subtend on the same chord PQ. Therefore, according to rule number 2, they are equal to each other. That is to say, X equals to 50 degrees. Okay, X equals to 50 degrees according to rule number 2. Okay, because of the fact that those two peripheral angles subtend on the same chord PQ, they are equal to each other. That is to say, X equals to 50 degrees according to rule number 2. So we found out that according in the first method, in the second method, also that X equals to 50 degrees. Okay, or in other words, angle PSQ that equals to X, here angle PSQ that equals to X is equal to 50 degrees. Okay, so in the next step, I will summarize the lecture. Okay, so actually we wanted to find out the size of angle X, angle PSQ, and in the first method we actually made a construction in the first method. We made a construction, we extended side QR by a straight line, and then from point S, we drew perpendicular to the extended QR. We defined the touching point between the perpendicular to the extended QR as point N. So this angle is 90 degrees because SN is perpendicular to QR. This angle equals to 90 degrees. And then we drew perpendicular from point S to PR. And we defined the touching point between the perpendicular to PR as point M. So this angle equals to 90 degrees and this angle also equals to 90 degrees because SM is perpendicular to PR. Okay? And then here we extended QR by a straight line, so actually QN is a straight line. Okay? So QN is a straight line. So if we focus at point R, we have the rule that states that the sum of the angles on one side of the straight line equals to 180 degrees. So if we focus on this side of the straight line QN, the sum of the angles must be equal to 180 degrees. So that is to say 50 degrees plus 65 degrees plus the size of this angle that is defined as Z must be equal to 180 degrees. 50 degrees plus 65 degrees plus the size of angle Z equals to 180 degrees. So we subtracted 50 degrees from this equality and we got that 65 degrees plus angle Z plus equals to 180 degrees. We subtracted 65 degrees from this equality and we got that angle Z equals to 65 degrees. We found out that this angle equals to 65 degrees. Then we actually focused on those two right triangles and we proved that those two right triangles can go into each other. So we focus on the right triangle, triangle SMR, and on the right triangle, triangle SNR. We actually have here a common side. We have here a common side that belongs to both triangles. So SR equals to SR as a common side. We also know that those two angles are equal to each other. They are both right angles. And those two angles are also equal to each other. They are both equal to 65 degrees. So if we have here two triangles that we know that the sum of two angles of them equals to 155 degrees, because 65 degrees plus 90 degrees equals to 155 degrees. So in order to complete the sum of the angles on the triangles to 180 degrees, then the third angle must be equal to 25 degrees in both triangles. So those two angles are also equal to each other and they are both equal to 25 degrees. So we actually proved that those two right triangles can go into each other according to angle rule. We have two angles and the side that attach to those two angles that correspondingly equal on the other triangle. Those two angles and the side that attach, that is to say SR, are correspondingly equal to those two angles and the side that attached SR. Therefore, those two triangles can go into each other according to angle side angle rule. From the fact that those two triangles can go into each other, we can conclude that SM equals to SN. According to the rule that corresponding sides and congruent triangles are equal to each other. So SM equals to SN, then we focus on triangle, the right triangle, triangle SMP, and on the right triangle, triangle SNQ, and we prove that those two right triangles can go into each other. First of all, we just right now proved that SM equals to SN. Then we know that SP equals to SQ. It is given us the question. and we proved that PM equals to NQ. We proved that PM equals to NQ. Why PM equals to NQ? Because actually PM, according to the Pythagoras theorem, we know that a triangle SMP is a right triangle. Therefore, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, SM square plus PM square equals to SP square. In these right triangles, we subtracted SM square from this equality, and we got that PM square equals to SP square minus SM square. We took a root out of this equality, and we got that PM equals to the root of SP square minus SM square. Then we focused on the right triangle, triangle SNQ, according to the Pythagoras theorem. In the right triangle SNQ, SM square plus NQ square equals to SQ square. Then we subtracted NS square from this equality, and we got that we subtracted NQ square from this equality, and we got that we subtracted NS square from this equality, and we got that NQ square equals to SQ square minus SN square. Here we took a root out of this equality, and we got that NQ equals to the root of SQ square minus SN square. But actually those two expressions are equal to each other because of the fact that SP equals to SQ according to what is given as the question, and we have already proved that SM equals to SN, so those two expressions are equal to each other. Therefore, PM is equals to NQ. PM equals to NQ. Therefore, we actually proved that the right triangle SMP is congruent to the right triangle SNQ according to side rule. From the fact that those two right triangles congruent to each other, we can conclude that angle NPS equals to angle NSQ. Those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So if this angle SPM equals to theta according to our definition, then angle SQN will be also equal to theta because of the fact that those two angles are equal to each other. Then I presented to you rule number one. Rule number one states that if a line segment subtends two equal angles on the same side, then the quadrilateral is inscribed by a circle, and the 4 points lie on that circle. So here we have two equal angles, both of them equal to theta, and they both lie on the same line segment SR. Therefore, according to rule number one, the quadrilateral SRPQ is inscribed by a circle, and the 4 points SR, P, and Q lie on that circle. The quadrilateral SRPQ is inscribed by the red circle, and the 4 points SR, P, and Q lie on that red circle. That is according to rule number one. This drawing is actually the implementation of rule number one in our drawing. Okay? Again, because of the fact that those two equal angles lie on the same segment line SR, according to rule number one, the quadrilateral SRPQ is inscribed by a circle, and the 4 points SR, Q, and P lie on that circle. Okay? And then we have rule number two that states that peripheral angles that subtend on the same chord are equal to each other. We have here those, those two peripheral angles, X and PRQ, that equals to 50 degrees, both subtend on the same chord PQ. Therefore, according to rule number 2, they are equal to each other. That is to say, X equals to 50 degrees. X equals to 50 degrees. Okay, that was method 1, and we actually also proved, we found out the size of X according to the second method. According to the second method, we actually extended SR, and then from point Q we drew perpendicular to the extended SR, so this angle is 90 degrees, and then we extended QM in such a way that Q dash M equals to QM. Again, Q dash M equals to QM according to our construction, and then we join together points R and Q dash by a straight line, and we join together points S and Q dash by a straight line. Okay, then we actually extended SR by a straight line, and SR is the side of quadrilateral, is a straight line, so SM will still remain a straight line. So, and we have a rule that states that the sum of the angles on one side of a straight line equals to 180 degrees. So we have here 65 degrees plus 50 degrees, plus the size of this angle must be equal to 180 degrees. That is to say, 50 degrees plus 65 degrees plus the size of angle, that must be equal to 180 degrees. So we subtracted 50 degrees and 65 degrees from this equality, and we got that the size of angle Z is 65 degrees. Okay, then here QM is perpendicular, therefore it is a straight line, and we extended the straight line QM by a straight line. So QQ dash will remain a straight line, and we know that the sum of the angles on one side of the straight line equals to 180 degrees. So if we focus on this side of the straight line QQM, at point M the sum of the angles must be equal to 180 degrees. That is to say, 90 degrees plus the size of this angle, that is defined as L, must be equal to 180 degrees. We subtracted 90 degrees from this equality, and we got that the size of angle L is 90 degrees. That is to say, this angle is a right angle. Then we actually focus on these two right triangles, and we prove that those two right triangles can go into each other. First of all, we know that QM equals to Q dash M. That is true according to our construction, and we know that those two angles are equal to each other. They are both equal to 90 degrees, and we also have here a common side, RM equals to RM. Therefore, we prove that those two right triangles can go into each other according to side angle side rule, and therefore those two angles are equal to each other. So if this angle equals to 65 degrees, then this angle must be also equal to 65 degrees according to the rule that corresponding sides and congruent triangles are equal to each other. And also QR equals to Q dash R according to the rule that corresponding sides and congruent triangles are equal to each other. Okay, and then we focus on the two triangles, the two right big triangles, triangle QMS and the right triangle Q dash MS, and we prove that those two right big triangles can go into each other. First of all, we know that QM equals to Q dash M. That is according to our construction. Those two angles are equal to each other. They are both equal to 90 degrees. And SM is a common side. It belongs to both triangles. So SM equals to SM. Therefore, those two triangles can go into each other according to side angle side rule. From the fact that those two triangles can go into each other, we can conclude that SQ or QS equals to Q dash S. And we know that QS equals to Y, therefore Q dash S will be also equal to Y. Okay, then we focused on the triangle SRQ and then on triangle SRQ dash, and we proved that those two triangles can go into each other. Okay, first of all, we have already proved that RQ equals to RQ dash. And we also know, we have already proved that SQ equals to SQ dash. They are both equal to Y, according to what we have already proved. And we have a common side, that is to say SR belongs to both triangles. So SR equals to SR as a common side. So we proved that those two triangles can go into each other according to side rule. And from the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other. So if this angle is theta, this angle also will be equal to theta because of the fact that they are equal to each other. Okay, then we proved that line segment PQ dash is a straight line. How we prove that line segment PQ dash is a straight line? By calculating the size of angle PRQ dash from this side. The size of angle PRQ dash is actually 50 degrees plus 65 degrees plus 65 degrees. This is actually 180 degrees. So because of the fact that angle PRQ dash from this side equals to 180 degrees, we can conclude that PRQ dash is a straight line. And if PRQ dash is a straight line, then PQ dash is also a straight line. And from the fact that PQ dash is a straight line, we can conclude that shape PSQ dash is a triangle. So in triangle PSQ dash, we know that PS equals to SQ dash, and we have the rule that in front of equal sides in the triangle there are equal angles. Therefore, those two angles that are located in front, the equal sides, will be also equal to each other. So if this angle is theta, this angle is also theta. So from now on, we continued according to method 1. We have here two angles that are equal to each other. They're both equal to theta and they subtend on the same segment line SR. Therefore, according to rule number 1, the quadrilateral SRQP is inscribed by a circle, and the 4 points SRQP lie on that circle. Okay, the quadrilateral SRQP is inscribed by a circle, and the points SR, P and Q lie on that circle, as you can see from the drawing. And we have also rule number 2 that states that if you have two peripheral angles that lie on the same chord, then they are equal to each other. So we have here angle X that lie on chord PQ, and angle PRQ that equals to 50 degrees lie on the same chord PQ. Therefore, they are equal to each other. That is to say, angle X equals to 50 degrees according to rule number 2. So we found out in both methods that the size of angle X, that is actually PSQ, is equal to 50 degrees. Okay, thank you very much.